Okay, so the last slide in this section is we're just going to take a look and see if there's an association between two variables. If there is an association, then knowing the one value of a variable helps predict the value of the other variable. If knowing the one value of the variable does not help you predict the value of the other, then there's no association. So let's just take a minute and look at our slides with our young adults and our opinions about getting rich. All right, is there an association? Is there not an association? If we take a look at this, male and female pretty much have the same opinions about whether or not they can get rich. About 30% of them think there's a 50-50% chance. About 30% also think there's a good chance, and about 20 to 25% think it's almost certain. So we cannot use the fact that they are male or female to help predict what their opinions are going to be about getting rich. So in this case, we would say there's no association between the two variables. However, maybe we were looking at sports. All right, let's say that we're looking at Pittsburgh residents and Cleveland residents, and we're checking to see what football teams they favor. Well, maybe the majority of the Pittsburgh fans favor the Steelers, and maybe a majority of the Cleveland fans favor the Browns. We might say then that the city that we live in helps us to predict which team they're going to root for. Okay, so, but be careful here. It does not state that there is a correlation between the two variables. This is going to be really important. This will be specific to linear relationships between quantitative variables, which will be in the last section that we discuss. All right, so just keep in mind that just because there is an association does not mean there's causation. All right, so it doesn't mean if I live in Pittsburgh, it's going to cause me or make me become a Steelers fan. If I live in Cleveland, it's going to cause me or make me to become a Browns fan. That's not the case. I can just say if I live in Pittsburgh, I can predict that I'm going to be a Steelers fan. If I live in Cleveland, I can predict that I'm going to be a Browns fan. So just be careful with that. Just because there's an association maybe between young males and the fact that they will get rich doesn't mean that being a young male caused you to think you'll get rich. All right, and that's something that we'll deal with later on, but just keep that in mind. Association's okay. One can help predict the other. No association, there can be no prediction between the two, but one does not, there's no correlation, does not necessarily mean causation. So just because you have one doesn't necessarily mean it's going to cause you to believe, if you're male or female, cause you to believe your opinion of getting rich. All right, so in the next section, in this section, we just took a look at the distribution of categorical variables. So see if you can take a minute and fill in the blanks from what you learned in this slide and the next slide. Okay. And we'll be going over some of the stuff like lurking variables in upcoming units. So just make sure that in the next section, or make sure that you know how to make bar graphs and pie charts, decide how you can tell a graph is misleading, understand the difference between marginal and conditional distributions, and these two links down here are just links that you can make your own bar graph and pie charts, and if you even want to do that for your homework assignments, that's fine too. You can click on those and just copy and paste them into the link.